Hello dear students, today we are going to study how to show the presence of nitrogen gas in the air by a simple experiment. Let's look at the characters of nitrogen gas. Nitrogen gas, the most abundant element in our atmosphere, and also it is very crucial to life. It is a colorless, odorless, tasteless gas in Earth's atmosphere. Non-flammable gas. You can see this in this picture. Two nitrogen atoms joined by a triple covalent bond. This means it is a diatomic molecule. The nitrogen gas was discovered by the Scotch physician Daniel Rutherford in 1772. When he removed oxygen and carbon dioxide from air, demonstrating that the residual gas would not support living organisms or combustion. Further learning, you can click the link. Now, let's see the composition of air. Here, the largest portion of the composition of air consists of nitrogen and oxygen and argon and the carbon dioxide. Those gases we can call it as a main gases. Nitrogen nearly 78%, oxygen nearly 21%, argon 0.93% and carbon dioxide 0.037%. Then you can see here the very small portion, nearly 0.003% of consists other gases, which as water vapor, noble gases, methane, nitrous oxide, ozone, particles, chlorofluorocarbon. Now, let's see the nitrogen as an element. In the periodic table, you will know that nitrogen is a group 15 element of the periodic table. The color of this, you can see this color of this box is indicated it's a non-metallic element. And also you see here is a nitrogen as a name is indicated here. The symbol is capital N. Electron configuration or electronic configuration of this element is 2s2 2p3. The atomic number is 7. And also in the physical state at 20 degrees Celsius, you can see here dot lines. It indicates it's a gas molecule. And the crystal structure, this indicates the crystal structure, it's a hexagonal crystal. And also in this position you can see acid-base properties of iron valence oxide. So in here you can find it that it's a strongly acidic one. And also you can see the atomic weight here. There are two allotropes, so the atomic weight are given separately. Right. Now we're going to move to see the experiment, a simple experiment to show the presence of nitrogen in air. For that purpose, we need some equipments. You know these equipments well. The first one is crucible with lid. The second one is clay triangle and crucible tongs, tripod, glass rod, Bunsen burner, sandpaper, dropper and pH paper. And also you need some chemicals. First one is a magnesium ribbon and Nistler's region. Now, before moving to the lab activity, can you answer this question? Can you write the balanced equation when magnesium exposed to air and when it burns in air? Right, from that one you well know that magnesium is highly reactive with oxygen, and you can see two magnesium solid is react with the O2 gas and form 2 magnesium oxide compound. When you are going to do this practical in your lab, you must be careful. First, you want to take the cleaned or rubbed magnesium piece and you should hold with tongs and do this practical. While you are doing that practical, you should not look directly at burning magnesium, because the very bright flame, a light and also intense heat will be produced. So you must be very careful. Now let's look at this video how bright when the magnesium is burned in air. Here you can see it's a very bright flame. Now the second question is, can you write the balanced equations for magnesium oxide and magnesium nitride? Both react with water. Yes, I know. Magnesium oxide is a white solid and it's react with water and form magnesium hydroxide. It's also white color one, precipitate. And magnesium nitrate is react with 6 water molecules and produce 3 magnesium hydroxide. And also you can see one gas is released here. It's an ammonia gas. It's a colorless one. When you do this practical in your lab, you should be careful. The magnesium nitrate can cause irritations of the eyes, skin and respiratory tract. Ammonia is toxic when inhaled, can cause chemical burns and is very toxic to aquatic life. Before doing the experiment in your lab, you should take some more precaution. Use protective eyewear and gloves. Never look directly into the crucible with burning magnesium strip. And do not touch anything without precautions, because everything is hot. So do not, and most importantly, do not inhale the gas, because ammonia gas is produced here from this practical. So you must be very careful. Right. And also, most importantly, my Google site or my YouTube channel don't take any responsibility for damage done to persons or property caused by this experiment. Right. Now, let's move to practical setup. First, you should take the magnesium ribbon and clean a piece of magnesium strip with a sandpaper. You already know magnesium is highly reactive with oxygen and form oxide layer. For remove that oxide layer, we are clean the piece of magnesium strip with the sandpaper and cut the magnesium ribbon into very small pieces. You can see like this. Then place the magnesium pieces in the crucible and close it with the lid and heat the crucible about half an hour. While doing this practical, while it's in the crucible in the Bunsen burner, do not open the lid while eating. It's very dangerous because the highly intense heat and also bright will be there. Then allow the crucible to cool in the room temperature. Then add a little amount of aqueous of Nestle's region to the white residue. Then what is your observation? right? You know, the Nessler region is a pearl color. Now here you can see we add some Nessler region to the residue. So you can clearly observe the dirty brown color precipitation is formed. So what is your conclusion? Can you guess, guys? Right. This experiment shows the presence of nitrogen gas in air is demonstrated by forming magnesium nitrate when a piece of magnesium strip is burnt in air. You can write the balanced equation. Likewise, 3 magnesium solid is reacted into gas and form Mg3N2 solid, this means magnesium nitrate. Then, for detecting the ammonia gas which is formed upon reaction with magnesium nitrate with water, you can see in this equation the magnesium nitrate is reacted with 6 water molecules and 3 magnesium hydroxide and 2 ammonia gas. You know well the magnesium nitrate is a pearl yellow solid. Magnesium hydroxide is a white precipitate, and also the colorless gas is formed here, ammonia gas. Then to detect the ammonia, we add Nessler's region, and Nessler's region, when we add the Nessler's region, the color change would be a dirty brown or a deep brown color. Okay, dear students, I think you can know now how to do a simple experiment in your lab to show the presence of nitrogen gas. Hope you understand this and you enjoy this lesson. Next time we will meet again soon with very interesting videos.